Why is Planck's length considered as the limiting value? So this is the topic of discussion in today's lecture. So here the topic is Planck's length. Why it is considered as the limiting value? You know, the value of numerical value of Planck's length is 1.616255 into 10 to the power minus 35 meter. This is Planck's length, and the mathematical expression of this is root over of h bar into capital G divided by c square, where h bar is reduced Planck's constant, capital G is universal gravitational constant, and c is speed of light in vacuum. So this is the mathematical expression for Planck's length, and Planck's length is a natural unit. And in the right hand side what appears? H bar, capital G and C, all are universal constants. So that means the Planck's length represents something about the universe, because all are here universal constants. So actually what happens in case of theoretical physics? Yes, I am talking about the topic which is in the realm of, which is discussed actually in the realm of theoretical physics, and the topic is actually quantum gravity. At this length scale or below this length scale, the numerical value I have already mentioned. At or below this length, the space-time becomes foamy. You know that according to general theory of relativity, space-time is a smooth curve, smooth and continuous curve. In general theory of relativity of Einstein, space-time is described this way. But at this length scale, means I am talking about Planck's length scale, here the space-time becomes foamy. It doesn't remain smooth because, due to the presence of Heisenberg's uncertainty principle. You know that according to that principle, the pairs, that is position and momentum of a fundamental particle, cannot be measured precisely. Okay, so that is Heisenberg's principle, that is known to you. And if you want to apply that Heisenberg's principle in this case at this length scale, then tremendous amount of energy will be required. Tremendous amount of energy means immense energy will be required to precisely measure any parameter such as position. Yes, and that vast amount of energy could form a black hole which may swallow the information about the position, or information about the momentum, or information about other parameters. So the study of physics at this length scale becomes a new physics. Means our known knowledge of general theory of relativity, our known knowledge of quantum mechanics cannot be applied easily at this length scale. That's why this length scale is so interesting. It is a fascinating topic in the realm of theoretical physics. Both the principles of quantum mechanics and the theory of theory of relativity, means I am talking about general theory of relativity, both break down at this length scale. That's why this is so important. This is the significance of Planck's length scale, and that is why this length scale is called the limiting value. Yes, a totally new physics could emerge if you become able, means if physicists become able to accurately describe the phenomenon at this level. Okay, so and one more thing I want to add to this, that in case of string theories, you know string theory, there are so many types of string theories are there in theoretical physics, and in string theory, the length scale which is considered is this length scale, Planck's length scale, or below this. Means in string theories you know that concept of strings are there, and which is not 3-dimensional or 4-dimensional, which is actually 10-dimensional, and those strings vibrate at this length scale. Our concept of space is 3-dimensional, and if you include time also with this, according to special theory of relativity, you know that space-time, so 3 dimensions of space is there and 1 dimension of time is there, but in case of string theory 10 dimensions are there, one of which is time. Anyway, in the case of string theory also, the length scale which is used theoretically is the Planck's length scale. So this is the significance of Planck's length scale, and why this is called the limiting value. I have already explained that thing. Okay. So this was all about today's lecture, today's topic. So this is the end of this video. Thank you for watching this video.